Hello and welcome to another wonderful day in math with Mr. Sims. Today what we're going to be doing is we're going to be doing our day 6 test incentive. So in other words, this is the incentive just to study for the test. Basically, follow along with me on the problems, copy it down on a piece of paper as I'm doing it, and make sure that as you're copying it down that you're listening very carefully to things such that like small little things that I'll tell you, because if you don't have those things on your paper, you won't get credit for the incentive. I want you to be able to get incentive for the credit for the incentive. So what I need you to do at this point, make sure you have a paper handy. Like I said, at the top of the paper, go ahead and write your name. All right, at the top of the paper, upper right hand corner, write your name, first and last name as always. And then underneath that, this is going to be the first thing, write Algebra Rocks. So just once again, you're going to write Algebra Rocks. Algebra, A-L-G-E-B-R-A, Rocks, R-O-C-K-S, at the top of your paper. All right, without further ado, I'm going to go ahead and move on to the actual math. Basically, what I'm going to do is I'm going to see how much I can get done in about 30 minutes. After 30 minutes, we're just going to call it good. So, Alexa, set a timer for 30 minutes.
30 minutes, starting now.
All right, so when my Alexa timer goes off, we're just going to call it good from there. So let me go ahead and move on to this. Sorry, it's been just a little bit since I've done this, so I always have to remember how to kind of do everything I want to do. All right, so the first thing we're going to do is look at basically a simplifying radical. So what I need for everyone to do at this point is go ahead and make your table of perfect squares. You guys go to the piano room now. All right, so what we're going to do, sorry, I was talking to my kids. So, all right, so what we're going to do is make our perfect list of perfect squares. So I'm going to go ahead and make that in. Let me make a new layer here. This new layer I'm going to call, let's call it writing. All right. So if I'm making my, whoa, that's way too big. Okay. Here we go. So 1, yeah, there we go. So if I have 1 squared, right? 1 squared is 1. 2 squared is 4. And I'm not going to write all the ones on this side because that's just going to take me a lot of time. But you get the idea. 3 squared is 9. 4 squared is 16. 5 squared is 25, right? 6 squared is 36, right? 7 squared is 49, right? 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And finally, 15 squared is 225. So what I have now is I have my list of perfect squares all the way up to 15, right? I didn't write all the little square numbers here, but they are, assume they're there. So what I need to do at this point now is I need to literally just divide this 405 by all of these numbers here. And so that's what I'm going to do right now. I'm going to give you just a moment. You can do that on your own as well. I have a calculator here. Let's see if it has batteries. It does not. I might have to go get a calculator real quick that has batteries. Give me just 1 second. All right, well, it looks like I have actually left my calculator at school, so I'm literally going to be using a 4-function calculator for this, and it will work. So, okay, square root of, so once again, I have this 405 here. So a problem like this, you need to take this and you need to start dividing it by all of the perfect squares that you can. You want to start with the largest one that you can, and then you want to move up from there until you get to 1. And you really never need to divide by 1. It's pointless. So I'm going to start with 405. And what I'm looking for is I'm looking for it to give me a whole number. So 405 divided by 225 did not do so. 405 divided by 196 also did not do so. 405 divided by 169 also did not give me a whole number. 405 divided by 144 also did not give me a whole number. 405 divided, and this is literally what you're going to do. There's tricks that you could do to maybe find a little faster, but I'm just going to go ahead and just do literally the whole thing until we get one that works. And finally, when I did 405 divided by 81, I got a whole number. What I got was 5. So in other words, 405 has two factors. That 405 has one of my factors, which is, that 405 has one factor, which is the square root of 81. And the number I got when I divided it by 81 was 5. So the second factor is the square root of 5. So I have the square root of 81 and the square root of 5. Well, the nice thing about this is this one here, because we know it's a perfect square, is going to simplify, because 9 squared is 81, it's going to simplify to these, not the square root, sorry, to 9. And then the square root of 5 just stays like that. 9 square roots of 5. And that's my final answer. So that's how you do problem number 13 on the study sheet. All right. So at this point, you should have had your name up on the upper right hand corner. You should have also, like I said, written Algebra Rocks right underneath your name. Here's what I want you to do now. Draw a heart at the bottom right hand corner of your paper. Once again, draw a heart at the bottom right hand corner of your paper. Just a small one. All right, here we go. Moving on. 45 minutes before he can go to the movies with his friends, he has already, Jackson's mom told him he has to do chores for at least 45 minutes before he can go to the movies with his friends. He has already been doing chores for 22 minutes. The inequality shown can be used to find M, the number of minutes Jackson has left to work. Which inequality represents the solution set for this situation? So essentially what they're saying is this is a scenario here that's modeled by this expression or this inequality. So because we already know that this is the inequality for it, really all of this up here only really doesn't have any purpose for us anymore, because we know that this is what we need to work with. So when you see a lot of writing and then they give you like the equation, a lot of times this writing is just kind of giving you a background for this. So this is actually what's really important. Don't always take that as the way you should think about it, but it does help you a lot of times if you're freaking out about all the wording, okay? So basically what I have is I have this inequality, and they want me to find the solution set. So in other words, they want me to solve for M. So what I'm going to do to solve for M, I'm going to do it right here. M plus 22, I'm just rewriting it now, is greater than or equal to 45. All right, so since I have it here, what I'm going to do is I have a variable and I have a constant. Well, if this is my variable, I want to isolate that variable, so I got to get rid of the constant. The way I'm going to do that constant is being added to it, so I'm going to do the inverse operation, which is subtraction. So I got to do it to that side. Well, if I do it to that side, I also have to do it to this side. So I get, when these are going to zero out, right? If you do it like Mrs. Westall does it, you do that cute little z. And this is M is greater than or equal to 45 minus 22. Well, that's going to be 23, right? Yep. Yep. So 23. So M is greater than or equal to 23 is the solution set. Now, this one here, they flipped it around. I didn't need to flip it around because I never divided or multiplied by a negative. So this is my answer right here. That's answer choice what? Answer choice D. All right? Make sense? All right, hopefully everyone's doing great still. I'd ask if there's any questions, but you can't ask me questions, can you, on a video? So here we go. What's the domain of the relation shown on the graph? So this one really is one of those ones where you need to be aware of what the terminology means, right? If you know what domain means, then you're going to be much better off in this case. So domain means all the possible x values. So, and in this case, you can look at the data. If I were to ask you if this is discrete or continuous, hopefully you could tell me it's discrete because there's individual points. There's not a line, right? So I know that my domain, since my domain is discrete, I know it's going to have this beautiful braces solution set, and it's going to have individual numbers within there, right? So it's all the possible x values. So if I wanted to, what I could do, if I wanted to, I could literally list out every single coordinate pair. 1 comma 3, right? 1 comma 3 is this one. This one is 2 comma 1, right? I could do that. And I wouldn't be wrong if I did that, okay? This is not the easiest way, in my opinion, to do it because it's just extra work. But if this is what it takes for you to get it right, then go ahead and do it that way, okay? The next one is 5 comma 0 for that one. And finally, this one is 6 comma 6. All right, so what I have is I have all my coordinate pairs, right? And remember, domain is talking about all of the x values, right? So since it's talking about all the x values, basically, it is all of these right here, okay? All of those, not the ones on the right, right? So in that case here, what I'm going to do is I'm going to make my braces, right? Because remember, a solution set always has to be in braces because it's a set of data, right? Well, what was that? That's not what I wanted to do. Let me try that again. Okay, there we go. All right, so what I'm going to do now is I'm just going to make my my braces, right? And I got my braces on this side too. Actually, I don't like to draw those braces until I'm kind of done. And remember, the biggest thing, not the biggest thing, one of the most important things about this is always do it in order from least to greatest. So I have 1, 2, 3, 4, 5, 6. So I'm just going to put them in order from least to greatest. 2, 3, 4, 5, and 6, right? All right, well, that's a terrible brace on the end. Let me fix that. There you go. And that right there is my final answer. That is my domain of the relation that's shown on the graph. All right. Now, you didn't have to write out all of these. I just did that for your benefit. You could just realize, okay, it's the x values. So I have x of 1, I have x of 2, I have x of an x value of 3, right? I have an x value of 4. I have an x value of 5 and an x value of 6. And you could have done it that way, right? And not needed to draw all of these. But I just wanted to show you that that's what it means so you could understand, all right? Sorry. Don't forget, always from least to greatest. All right. So far, we are cooking right along. We've actually done 3 problems. Let's quickly review what we've done. We did the radical one here. Don't forget, you can always review these to make sure you get them right. We did this one where we had to simplify this solution of the inequality, right? Now we did this one with domain. And once again, domain is the x values, and we figured that out. So now we're going to do one where we are actually going to use this chart from earlier, right? We're just going to use it on this side here. So let me see. I'm going to x squared is equal to 112. I could go ahead and make the chart again, but since I made it earlier, I'm just going to refer back to it. So remember, x squared is equal to 112. This is a one-step equation here. The operation present is squaring. So I want to get rid of that squaring. And the way I get rid of that squaring is by taking the square root of both sides. Well, the square root of a squared number, a squared letter is going to be x, right? And remember, whenever you take the square root of a number, you're actually going to get 2 answers. You're going to get a positive answer and a negative answer, because a negative times a negative, right? If you multiply a positive times itself, you'll get a positive, but if you multiply a negative times itself, you also get a positive. So our answers, whenever we take a square root, there'll always be a positive and a negative answer. So that's why I have the plus or minus symbol. And I have plus or minus the square root of 112, whatever that is. So at this point, what I need to do, I need to take that 112 and just start dividing it by that list that I had earlier. So once again, I'm going to take 112. I'm just going to start dividing it by these numbers until I find one that works. Obviously, I don't have to do anything bigger than 112, right? So I'm going to start with maybe 81, 181, 64, so on and so forth. So let me go ahead, and I'm looking once again for that number, when I'm done dividing 112 by it, it should give me a whole number. So 112 divided by 81 didn't work, divided by 64 didn't work, 112 divided by 49 didn't work, 112 divided by 36 didn't work, 112 divided by 25 didn't work, 112 divided by 16 worked. Cool. All right, so what I found was that when I took my 112 and I divided it by 16, I got a whole number. That whole number that I got was 7. So what that tells me is that x is going to equal this plus or minus. This is going to be factored into two factors. The first one I found, once again, was 16, because when I divided it by 16, I got a whole number, and the whole number I got when I did that was 7. So in other words, 16 times 7 is 112. Those are two factors of it. 16 times 7 is 112. So at this point, the nice thing is 16 is a perfect square, so it simplifies. So I get x is equal to plus or minus 16. The square root of 16 is 4 square roots of 7. Ta-da! All right, hopefully this is making sense. Hopefully there's nothing too difficult for you yet, right? All right, so at this point, you should have already written your name in the upper right-hand corner. You should have already written Algebra Rocks right underneath it. You should already have a heart underneath it. Later on, I'll give you something else to do. But let's go ahead and make sure you got those things there. All right, I forgot to circle my answer. Always circle your answers so your teacher doesn't have to try and find it, okay? Here we go. Find the range of the following function. So range is a lot like domain. In fact, we did a problem with domain earlier, and range is the same exact thing, except it's not the x values, it's the what? It's the y values. So x basically, the domain tells us like what are all the possible x values. The range tells us what are all the possible y values. Well, here's my y, part of the graph, part of the table. So these here are all my, that is so ugly. Let me try that again. These here are all my possible y values. That's better. Not much better, but it's a little bit better. All right, so remember, I'm going to once again do a set, right? And I need to do it from least to greatest. In fact, let me leave that one off because I don't know how big it's going to be. So I need to do it from least to greatest. So I'm going to look at which one is my least value. My least value looks like it's -8, so I'm going to put -8. All right, comma. My next one is, looks like -1 here. So I'm going to -1, comma. Then I have 2. Then I have 3. Remember, with these videos, there's no shame in watching them again if you need to, if you just want to refresh, maybe even right before the test, you just want to watch it again in the library or something like that just to get it. There's no harm in that, right? This isn't all the problems that you have, but I chose a selection of problems that's, that if you do all these problems, that you'll probably be pretty well off, depending on how much time we have here. So anyway, -8, -1, 2, 3, 6, and 9, and that is my range. And so I'm done. And so far, hopefully you've noticed that there hasn't been a lot of problems that are terribly difficult. We try to start you off in a way that you can build some confidence, right? And the biggest thing is just don't get behind. You know, do all the things that you're supposed to do, and you should be fine. So let's look at number 30 now. Solve for x, right? So at this point, you have Algebra Rocks underneath your name. In the upper right hand corner, you have a heart at the bottom right hand corner. In the bottom left hand corner, what I would like for you to do is draw a bunny. That's right. In the bottom left hand corner, draw a bunny. All right. Without further ado, let's continue. So here, this problem they want me to solve for x. Let me just tell my children to be a little quieter. Hey guys, I'm still working. I need you to be quiet. Thank you. Love you. All right, so in this problem here, solve for x, what I'm going to do, I'm going to take and recognize that this is my term with the variable. And this is a constant that's on the same side as that. So this is what I need to get rid of first. And the way I get rid of that is by doing the opposite operation. So I'm going to add 7 to both sides. Remember, if you do it to one side, you have to do it to the other, otherwise you break the equation. And so what I get here is I get 10 is equal to 1/5 x. And what I want you to understand is you might see this 1/5 x a little bit different. If it's 1/5 x, a lot of times you might just see it as x over 5, okay? But in this case here, they made it a separate fraction, but it's just, those are equivalent, okay? X over 5 is the same thing as 1/5 x, okay? So anyway, in this case here, if x is being divided by 5 or being multiplied times 1/5, what I can do is I can actually, if it's if x is being really divided by 5 here, then what I could do to get rid of it, to get rid of that divided by 5, is multiply by 5. If I do that to one side, I have to do it to the other side as well. Well, these are going to cancel out, reduce to a fraction of 1, because 5 over 5, remember, 5 over 5 would be what? That'd be a 1 whole, right? Because you're saying I have 5 pieces. It takes 5 pieces to make a whole, and I have all 5 of those pieces. Therefore, that would be 1 whole. So what I have here is 1x, right? But we don't write the 1x. We just write x. So I have x is equal to 10 times 5, which is 50. So my answer is 50. All right. So once again, just to recap, I looked at the variable with the term with the variable. I looked at the constant that's on the same side. I did the opposite operation of that constant, which was adding 7 to both sides. And then I recognized that 1/5 x is really the same as x over 5, so I just multiplied by 5 on both sides. I multiplied by 5 here, so these could cancel out, leave me with my x. And then I did it on the other side as well. And I left with x is equal to 50. All right. All right, doing pretty good so far. Moving right along. Let's go with number 5. Solve for k. 56 is equal to 8k. All right. So 56 is equal to 8k. So what I'm going to do, you'll notice that this looks a little bit different, and the reason why it looks different is meant to freak you out a little bit, is not by us but just in general. They make problems like this to see if you understand what's going on. And here I recognize this is my variable. This is what's happening in my variable. It's being multiplied by 8. It doesn't matter that it's not on the side I'm used to seeing it on, okay? Because really I could flip these back and forth ad infinitum if I wanted to. If it really bothers me because it's an equal sign, I could go ahead and rewrite it like that if that makes it easier for me, right? But I'm not going to do that. I don't want us to get in the habit of just making things easier for no reason. So in this case here we have 8k. 8 being multiplied times the k. I want to do the inverse operation so I can get the k by itself. So I'm going to divide by 8 and divide by 8. And I get 7 is equal to k. And 7 is equal to k is my final answer. Once again, simple one-step equation, right? Haven't had to work too hard with that, right? The only difference is they flipped it around on you, but should be pretty okay. All right, let's go ahead and move on to the next one. Given that the set of ordered pairs below represents a function, which best represents the domain of the function? So this is actually a lot like what we did with this problem up here. Where'd it go? No, where'd it go? This one? No, this one, where we actually wrote the points down, right? Well, the thing is, they didn't show us the graph for this new one. They didn't show us the graph, but they did show us all the points. In fact, all those points are there. And what they're asking us for, what is the domain? And once again, the domain is which values? Hopefully you said x values, because that's the right answer for domain. Range is the y values, but we want the x values. So I'm just going to go ahead and underline my x values based on these coordinate pairs, these ordered pairs. And that's basically what I have. So now the only thing I need to do, and they've made it really easy for you. They've already put everything in order from least to greatest. So you didn't have to do a whole lot of work there with the multiple choice. But I'm looking for an answer that has -7 as my least answer, 2 as my most, and then -4 and 0 in between. So here's -7. This one has -5. You'll see -5 actually belongs to the y value. So this one is actually not part of the domain. So this one is wrong on account of that. This one is not part of the right answer. In fact, neither is this 4 or this 1. Basically, they took all the pieces. That's nothing, actually. This one here is -7, -5, -4, -3. So they've also done something weird. Let's not take that one either, because once again, that -5 is not part of the domain. That's a y value, right? So that's totally out. That -3 also is a y value, so that one's totally out as well. So let's go ahead and go -7, -4, 0, 2. Ooh, that one looks really good, actually. I think that's probably the right answer. I'm going to put a check mark just to remind myself that that's probably it. These are definitely out, right? But I always check all the answers just in case, it's like all of the above, or if I just made a mistake. Sometimes it's easy to make mistakes, right? So -5, -3, 1, and 4. What they gave me here was actually range. And I don't want range. I want domain because that's what the problem asked for. So domain, because they're asking for domain, my answer is C. Right? And once again, they put in least to greatest. That's great. Great job. All right. Then we have 2 more problems to do, and then we're going to call it good. So you've already got some good study in. Hopefully, you're following along with me, and this is making sense. At this point, you should have written your name in the upper right-hand corner. You should have Algebra Rocks underneath it. You should have in the bottom right-hand corner a heart, and in the bottom left-hand corner, you should have a bunny. In the upper left-hand corner of your paper, I would like for you to say, "Thank you, Mr. Sims." Yep, that's what you're going to say. Thank you, Mr. Sims. And yeah, go ahead and do that. All right, so here we go. Solve for D. Solving for D, once again, is basically just isolate D. That's what it means. When it says solve for D, it means get D alone. That's all it means. Get D alone when it says solve. So in here I have D minus 14 is equal to -8. So I'm just going to add 14 to both sides. And that's going to give me, when I subtract 8 from that, I'm going to get positive 6, right? And so I should get D is equal to positive 6. Once again, I did the opposite operation. Here's my variable. This is the operation present, which is subtraction. So I did addition of that same amount, 14. 14 minus 8 is 6, or -8 plus 14 is 6. So looking pretty good. D is equal to 6. Bada bing, bada boom. Don't forget always to circle your answers. And finally, for the last one of the day, here we go. Solve for x. 8x plus 14 is greater than or equal to 54. So this is a two-step equation. We know that because you have a term that has the variable. It's not just the variable alone. It's actually a term that has a variable. There's an operation happening to the variable. And there's also a constant. So this is the term with the variable. I'm going to deal with that in a second. Alexa, stop. Well, that's my 30-minute timer. Let's finish this real fast, and then we'll move on. So 8x is a term with the variable. Here's my 14. I'm going to subtract 14. I got it, sweetie. Thank you. So I'm going to subtract 14 from both sides. And so this is going to zero out. 14 minus 14 is 0, right? So I get 8x is greater than or equal to 54 minus 14, which is going to be 40. So now my operation present, this is now one step inequality. My operation present is is multiplication. So now I need to divide by 8. Now the only thing I would need to be careful of here is if this were -8 and I was dividing, I would need to switch the the symbol, right? I'd need to flip it. But because it's a positive, I don't need to do that. Basically, these just simplify to 1, and I just get x is greater than or equal to 5. But I just want to put that bug in your ear. Remember, if you multiply or divide by a negative with an inequality, you need to make sure that you what's the word I'm looking for? You need to make sure that you flip the symbol. All right, well, at this point, hopefully that all made sense to you. I really enjoyed working with you here today. Once again, I commend you for just the effort that you're putting in. Let's just look at what we did real fast, just a quick recap. We learned about simplifying radicals, right? We learned about how to make our table and then divide this number, this big radical, just by each of these, right? First thing you always want to do is make sure it's not just a perfect square. Just do the square root in your calculator. Make sure it doesn't give you a whole number just right off the bat. But yeah, I just divided it by numbers until I found one that works. And then when I divided by 81, I got 5 in my calculator. So that tells me that 81 and 5 were factors of it, right? So I got that 81. Then the square root of 81 simplifies to 9. So I got 9 square roots of 5, right? So I did that. That was fun. We learned that this one was a nice problem, but all of those words really were just there to explain what this is. And that really, once we understood that, we could just go with that and work with that inequality. And we did that pretty well, right? This one here, what's the domain of the relation? Pardon me. So the domain, once again, is the x values, right? And this one here, solving for x, is a lot like that first problem that we did, right? The only difference with this one was you had to actually write out the square root symbol, you know, and realize that x is plus or minus those, right? So x is, but then you did the same process. Once you got to this point here, you did the same exact process that you did over here, right? So, and you got, you know, that 112, you divided by all the numbers. When you got divided by 16, you got 7. So then that told you 16 and 7 were both factors. And then, you know, 16 simplified to 4. I'm not going to do this for all of them, but you get basically the idea. This is how we did it. We learned about range being the y values, right? And how to write it with the effective notation. We solved for x in a two-step equation here. Once again, recognizing what the variable term is and dealing with that other constant first. Then this one we did a one-step equation, and we learned it doesn't matter which side the variable's on, that we can still do it either way. This one here, we talked about the domain, the x values, if they give us the points, right? And then finally, you know, we did another one-step equation here and a two-step inequality here. And really, it shouldn't have been too bad for you. I think a lot of you guys really took it in stride. Well, anyway, without further ado, I'm going to get off. I promised you about 30 minutes, and that's about what we got. So I wish you the very best on the test. Thank you for studying. Don't forget to hand this to your teacher. So at this point, I just want to stress you should have already had 4 different things on your paper. If you forgot what those 4 things were, you missed them, make sure that you go back and you know, check through the video to make sure you got them, because if you don't have those 4 things on your paper, you're not going to get credit for the incentive. All right, well, I wish you the very best. Thank you very much, and have a wonderful, wonderful testing experience. Thank you so much. Bye.